series with battery of 20 volts. Find the current in circuit as a function of T. This is the applications of ordinary differential equations. Here resistance, the current flow with resistance, the resistance here this R, and the inductance L, and the voltage source are given here. The voltage source is the minus to plus. The current flow in these directions, and the current is I. Current is I. We have resistance R and L, inductance L, and the electric source, the voltage source is this E. This is sources volt. Source term in the differential equations. By Kirchhoff laws, the voltage, the current across this R and this L equals to the sum of the current across this R and this L is equal to the voltage source E. So by Kirchhoff laws, the current I R plus L di by dt. The changes of current with respect to time with multiplied by L. This is the current flow, sum of the current flow across R and L, which is equals to the source voltage source. This is source, and the current flow in this direction. This is the differential equation, first order differential equation. So from this, we form the first order differential equation. So this can be written as di by dt. Di by dt, the current I dividing L here, R by L. I is the current equals to E by L. Or here given that the resistance is the 100 ohms, and the inductance L equal to 0.5 Henry, and the battery volts, the voltage source is 20 volt. It's the volt source, the source term. So this right hand side, this term source terms E. So the differential equation, which is first order linear differential equation, plus R by L equals 100 by 20, 100 by L 0.5 equals to 200 I equals to E, 20 by L, 20 by L 0.5 equals to 40. This is first order linear differential equation. So we first find its integrating factor. This is the application of ordinary differential equation. We have already done that. The integrating factor is found by the formula, the e to the power 200. This is 200 dt. So the integrating factor is e to the power 200 integration dt. And its general solution is I is current into integrating factor. I into integrating factor. In the right hand side, the integration, the 40, this 40 into this integrating factor into I of d. This is the general solution to find out the current. So, or I is the current, integrating factor here is 200 T. In the right hand side, integrating factor, we write 40 e to the power 200 T dt. So its integrations is, we integrate this with respect to t. So integrate with respect to t in the right hand side. E to the power 200 T. E to the power 200 T. In the right hand side, this is I current, e to the power 200 T divided by 200. So this I e to the power 200 t in the left hand side. In the right hand side, that is 40 e to the power 200 t divided by 200. This is the integrations of e to the power 200 t. So after integration, we write here c or I, the current I equals to dividing it by 200t on the right hand side, and this 40 by 200 equal 1 by 5. 1 by 5 it 1 by 5 plus c e to the power minus 200t. This is general equation, general solutions of the differential equations, which is in current I, which is in terms of t. But here C is the general constant. But to find out C, in this figure, we see that initially the current is 0. At time t, initially at time t equal to 0, the current flow is also, there is no current flow, so I equal to 0. By using this initial condition, we find the general constant C. So using I equals to 0, t equals to 0, t initial time, I is also 0. This we use in this equation, in these solutions. I equal to 0 equals to 1 by 5 plus c e to the power 0 is 1. Therefore c equals to minus 1 by 5. C equals to minus 1 by 5. So the current is I is dependent on t. This equals to 1 by 5 minus 1 by 5 e to the power minus 200t. This is the solute current which is depend on t in this, in the differential equations. Here in the figure, its solution it is the current. Initially current flow start from here at time t equal to 0. Current flow starts from here, and the current is highly peaked into at time 0.01 second. At this point, this is the current, and then the current flow constant.